Hello and welcome to a short video where I explore some basic software rendering using SDL2. In this video I create a rendering of the Mandelbrot set. Starting off with a pre-made Hello World program, I first create a window class that I will use to manage my window throughout its lifetime and render my image to the screen. I start by adding some fields for SDL objects I think I'm going to need. Then I make a constructor to create these objects from width and height parameters. I start out by only initializing SDL and constructing the window. Then I create a function that goes through all the SDL events that have occurred to check if any of them are asking for the window to close. Now I go back down to my main function to test what I've created. At this point I realize I should probably also add a destructor to my class. Next I create some getters to get the screen width and height. I also did some extra research into ways to do software rendering in SDL and decided I'm no longer going to use the renderer or texture objects, replacing them with a surface object and a pointer that will point to the raw screen data. I make the surface and grab the pointer to the screen data in the constructor. I also print the pixel format to determine the format that SDL uses on my system. It's probably worth noting that while this method uses less code, it's a lot less portable than the renderer texture method I alluded to in the beginning. After determining that SDL is using plain RGB values with 8 bits per channel, I decide to try to create a loop filling the screen with red and black stripes. A quick test shows a nice black screen, meaning I clearly did something wrong. After some more wandering around the internet, I discover the update window surface function, which sounds like it might help, and to my surprise it fixes the problem. Then I fix my documentation and retest showing me all the stripy red lines I ever dreamed of. Now I move on to a render pixel function that I will use to plot my image. This function takes a screen space X and Y coordinate and an 8-bit grayscale brightness value. I then test this method by adding a pixel in my main method and ensuring that it appears on the screen. Next I create X and Y values to represent where on the screen I will be rendering, and make a function to linearly interpolate a point from an input space to an output space, even adding a comment, because sometimes I like to pretend I'm a real developer. Then I make the position variables scan across the screen in a raster pattern, remembering to stop processing pixels once the beam is off the end of the screen. Now I test my code again to verify that the screen is filling with white pixels, but painfully slowly. I add another loop so that I draw more than 1 pixel per frame, and this speeds up rendering quite nicely. I also decide I might as well ensure that the pixel I'm drawing is actually on the screen and not a random place in memory. Now that I have the screen drawing, I decide to test my lerp function by drawing a grayscale fade. This makes a fun pattern, but not what I was looking for. Once I correct the values I put into the lerp function, I get the output I had been expecting. Finally, I start work on the actual Mandelbrot set part of this project. I create a function that takes XY coordinates and a max iteration depth and returns the number of iterations that occurred. I create both real and imaginary components for the numbers Z and C and initialize them to X plus YI. Next I create a loop that breaks when the iteration depth is reached or the absolute value of X is greater than 2. Inside the loop I calculate Z squared plus C and then put it into a variable new Z, and copy this back into the original Z variables. Finally I return the counter once the loop exits. Finally I convert my screen space coordinates into Mandelbrot set coordinates. Then I calculate the number of iterations each point takes to leave the set, and render each pixel with a brightness proportional to the number of iterations. And after a last test run I finally get to see a beautiful rendering of the Mandelbrot set.